Recording in progress.
I was hanging with you and then I realized I didn't think it was true. I was surprised when I found out I'd fallen for you. I didn't want to believe my feelings for you. I didn't want to believe that I could lose you if I told you just how I felt. But I can't help it, I'm falling for you, and I can't quit it, 'cause I'm stuck on you. And it might be pathetic and you might be skeptical, but I just want to be with you. Please tell me, boy, can you get a clue or come through, 'cause I just want to be with you. I'm scared of telling you how I feel. Maybe it's better if I just try to conceal the truth for me and for you, but I'm still stuck on you. I'm still falling for you, for you.
But now he's gone and she's alone again. Maybe if she tried a little harder to find the gem within his heart that was there this whole time.
The pictures are really demonstration of how much fun and how great it was, how special it was for everybody. Many first timers, so I think we'll all remember it fondly. Okay, 8 pitches, easy peasy. It's gonna just go by. And they'll start in 3 minutes. Great. That's and good morning. I don't think so. I just read out. Right. There we go. So our first pitch, we have SuperNode, and here we have Andrew. Hi, Andrew. Hi, John. Welcome.
Good morning.
Hello. Hey, good to see you here. Welcome, welcome. So congratulations for making the top 63 Electrons 2025. Well done. And now you have an audience full of people, 30 people from 17 utilities anxious to hear more about your solution. And as you know, you have 6 minutes to pitch and then followed by 4 minutes Q&A by everybody who has questions. Are you up for it? Ready?
Yeah, we're ready. Thank you.
Okay, then the floor is yours.
Okay, let me just.
The presentation is up. It's starting to show. We see it very well. Okay, no, actually, we see your back. Now we do. You see,
Okay, is that okay? Okay, well,
That's
good
perfect.
morning. Good morning, everybody, and thank you for this opportunity. My name is John Fitzgerald, and I'm the CEO of SuperNode. SuperNode is an innovative technology company developing high-capacity superconducting cable systems, and particularly the next generation of superconducting cable systems. And why is that of interest to utilities? Well, I guess the problem is this: for 100 years, you guys have provided incredible reliability, and that's taken for granted. But in recent years, the ask has changed, and you're being asked to do more of energy from electricity, and the system was not designed for that. So the ask has changed, and that's very difficult to respond to. So data centers, renewable generation, demand, EVs, heat pumps, everything can happen so quickly, but it's very difficult to do linear infrastructure, specifically when there are a lot of environmental and built environment constraints to deal with. So congestion is a feature of the grids today around the world. Queues, curtailment, and frustrated stakeholders who just want to get connected and to electrify effectively. Superconducting high capacity cables are a solution for this because they can carry 5 to 10 times as much energy in the same footprint at the same voltage level than conventional cables. So they're not always faster, but sometimes they're not always cheaper, but sometimes they can be up to 50%. And there's a use case later, which I'll talk to that, but they're certainly faster. They don't generate heat, so they can go in existing corridors and existing ducts, reducing the civils, the substation work, and the disruption and time required to deliver grid as required. When this grid is in place, we're talking about greater resilience and reliability, because if you need 3 times the power transfer capability and a superconductor can give you 5 to 10, that's headroom, that's resilience in your system, in your network, and it future-proofs you against future needs that happen very quickly. The second generation, I should first talk about the first generation. And as you'll see here is a cable. These cable systems have been around for 25 years, solving local problems in cities around the world. They use corrugated steel to convey the liquid nitrogen because the superconductor needs to cycle up and down from ambient temperature to cryogenic temperature so it can deliver 5 times as much power. They're very good systems, but they're limited in the distance they can provide solutions for. SuperNode have taken oil and gas technology, polymeric high performance pipes, and modified them successfully for cryogenic use in this use case. They have 3 times less pressure loss, they're higher pressure rated, they're lighter, they're cheaper, they're road reelable. And you can see from the right, the assembly and manufacturing process is a combination of extrusion and wrapping processes that can deliver this infrastructure at scale and pace. So we're looking at something that's 30% cheaper than what's available today, that's better thermal performance, that's long distance enabled, so it can solve larger problems over longer distances. They're more installable and they could be readily manufacturable. What we see here is a cryostatic system that would make any superconducting project better. It's the most competitive superconducting cable system, and it unlocks a lot of use cases for utilities that are under significant pressure at the moment. In the past 18 months, we've been engaging with many utilities, some of you currently on this call, but notably National Grid and Elia, where we're working on use case development and cost benefit analysis. They've identified this technology as something that can be a game changer for them as they strive to meet their customer needs. The addressable opportunity. Superconductors could have a significant impact across your network. Between you, you have 1.9 million of kilometers under development in the coming years. EDP has 183,000 kilometers of network cables and a 10 billion grid development plan. E.ON, 700,000 of network cables and a 34 billion grid investment plan to 2030. And Hydro-Quebec, 260,000 kilometers of network cables planned and 50 billion grid of network investment. Superconducting cables could significantly help in delivering those plans and make them faster and cheaper. The use case I referred to earlier is the flagship use case for the industry. SuperNode are not directly involved in this project. It's a 15-kilometer project in the city of Munich that will deliver 500 MVA of power transfer capability in 110 kV voltage. With superconducting technology that we've developed, that project could be delivered without any need for intermediate cooling or pumping. The optioneering, the project could be shorter because it wouldn't need an intermediate cooling and pumping station. The project already delivers 40% saving on a conventional solution using 5 copper cables. We can improve that and give a total of 50% reduction on the conventional copper alternative, which is they would struggle to deliver And Munich is not unique in this situation. There are over 400 cities that have congestion issues that could do with significant upgrade of infrastructure without disruption. To achieve this, SuperNode propose and would like to collaborate on a type test 250 to 500 meters operating over 12 months that would validate the performance and the distance capability of this technology, 1.5 million to 2 million in cost. And we would deliver this and put you at the forefront of the technology. In summary, high capacity cables can do 5 to 10 times more power. They can deliver upgrades. We would love to work with you to deliver and collaborate and refine a pilot to your needs, and then to plan, deploy, and execute a commercial project. Thank you.
Thank you, John. Great. So that moves us into Q&A territory, and I open the floor for some questions.
Hello, John. It's Sylvain from Hydro-Quebec. Well, first of all, congratulations for making it to top 60.
Thank you.
Well done. So a couple of questions from our subject matter expert here. Will the cables going to be 3-phase AC or only DC?
Yeah, they'll do both. The cryostat is suitable for both. It's a different configuration, but it's compatible with both.
Okay, and what will be the design then? Concentric with one cryostat and 3 separate cables? And voltage also, if you could say a few words on this.
Yeah, so I'll invite Andrew Carlisle, our Chief Technology Officer, to answer that one.
Yeah, so it depends really on the voltage levels. For something like 110 kV 3-phase, we'd propose a triad configuration, so 3 separate phases individually located inside the cryostat in a triangle configuration. At lower voltages, you can do concentric phases, and then as you go up to very high voltages, the system needs to be split out into 3 separate cables.
So you suggest a pilot 250, 500 meters, but if we were to go shorter distance, say 30 meters for a first step, what would be the key test for evaluating your system? So the key test you would suggest?
Yeah, so we're actually already doing testing at the scale of 12 and 30 meter lengths ourselves, and that's primarily looking at some of the mechanical characteristics, so things like readability, thermal performance, and some other characteristics, as well as high voltage testing, so withstand testing, sheath testing, etc. This pilot would really be the next step, and starting to move more into a tight test arrangements with in the order of hundreds of meters of test loop to validate the full system. So the cooling, joints, terminations, the cable itself, in a type test scenario, effectively to qualify it for your applications.
Okay, and for very long distances, what about the configuration of the connection? Because I see on your first slide, you kind of show, yellow, whatever, values, or will they be like connectors or?
Sorry. Those are we call them field joints. So they're effectively the cables will be constructed in sections, and we're planning for sections up to 5 kilometers in length, and the sections then have a joint system. And again, it depends on whether it's AC or DC and the voltage levels. What you're seeing on screen is the concept for the DC, a DC bipole system, and the joints effectively are plugs. So that means that you can construct the cables in single pieces, transport them to site, and there's no splicing works or joining works done on site. It's effectively a plug system.
Okay, thank you. That's all we have time for right now for Q&A. Thank you very much for your pitch. Again, congratulations. And
Thank you very much.
Thanks, everybody.
Bye.
Thanks. Thank you.
SuperNode team. To leave the room, you have a button on the bottom right. Let's leave the room. Thank you again. Next up, we have ZeroParallax. Yes, we have Gigantas, and he is. Where is Gigantas? Yeah, joining. Online. Gigantas, how are you doing? Welcome.
I'm doing very well. Hi.
Hi, so welcome to Free Electrons pitch session. Congratulations for making the top 60. No mean feat. And well, we have here 30 people from 7 utilities really anxious to know more about your solution. As you know, we need 6 minutes for your pitch, followed by 4 for Q&A.
Yeah.
Are you up for it?
Of course.
Ready
That's
to-
why I'm here.
There you go. So if you want to put your presentation up,
Wait a second
we
there.
can start whenever you're ready.
So, do you see
Coming up.
my screen?
We do. We do. It's well presented. Go
All
ahead,
right.
you got this.
So my name is Vigantas, and I'm a co-founder and the CEO of ZeroParallax Technologies. So we started 10 years ago from designing our own optics and electronic systems for industrial sensors. And about 5 years ago, we have finished our sensor together with Mitsubishi Corporation. What is unique about it, it's important to know. It's a unique sensor that has 180 degrees field of view, can measure temperatures in every pixel, and has quite large edge computing capacity. So it's able to monitor large areas. So also last year, we have launched our software and service layer for this. It's called Zero Tools, and Zero Tools essentially is a health tracker for your substation. So whilst irregular thermography inspections are good and they are accurate and they are absolutely necessary, they do happen periodically, and there is plenty of time for issues to develop and things to go wrong. So Zero Tools is changing that essentially, where we track your substation assets continuously. We use the data and then we guide engineers to be in the right place and on the right time. So how it works, I will share a little bit of our software. Tell me if you see.
Yes.
Okay. So what happens is that we are mounting 1 or 2 sensors on a substation. We take a reference image of a substation. So this is a still. This is not a live picture. This is a reference image to mark out all your assets in the substation the way that you would want to monitor. Once you do that, the monitoring starts. Of course, this is not really where we collect the data. The data is collected from our thermal sensor, and as soon as the data is being tracked and thermal behavior is being tracked, our algorithms kick in. So we have a set of algorithms that are analyzing the behavior in specific scenarios and triggering alerts and messages once these scenarios have been realized. Now, today we have also AI systems to do the analytics on this behavior and give out maintenance recommendations, so you would know where and how and what is happening. Of course, you can also use the data for the analysis of the situation afterwards as well. So, of course, there's also real-time data in dashboards, etc. So you can have this on your mobile devices as well. So I'm going to switch back to the presentation to just finish it up. So what are the potential benefits of this? And this has been extensive research has been done on this. It's reducing maintenance costs by up to 30%. It may reduce the frequency of outages up to 30%, duration of the downtime up to 50%, and extension of the substation lifespan up to 25%. So it's a significant impact on the bottom line. Here is how our typical pilot looks like. So typically we select a site, prepare a project, takes about 1 week. We sign off on that project. Then we do some preparation work, so like stressing the system, network setup, agree on some details, power routing, etc. And then comes installation date. Installation takes 1 to 2 days, after which we track the substation for 12 to 16 weeks. The other times can be arranged. And eventually, a large report comes out with all data collected. Typical pilot budget, 50 to 70K euros. If we need to travel to Australia, probably a bit more. Many thanks for you, and maybe you have some questions.
Perfect, Gigantes. Yes, we have some questions for you.
Thank you, Gigantes, for the great page, and congratulations for making it to top 60 this year. My name is Ivan from CR. My first question is what is the typical faults that you think your solution can be like monitored in a substation? What type of like equipment it can monitor? Switchgear, transformer.
So this, as you see, we have 180 degrees and very high resolution, and we mark out every equipment available. So every connector, every bus bar, every circuit breaker. Typically in the small substation, we can do 200-300, and the large ones up to several thousand regions of interest. So everything that you can see, you can measure.
Okay. Do you think you can like forecast those like for early fault detection?
Sorry,
if your thermal scanner can like detect some abnormal temperature, can it like, do you have like any AI to like analyze those images in order to like determine whether it's potential fault or?
Yeah, so absolutely. So first of all, we use AI for detecting the assets, and we use AI for analyzing the asset behavior. We have dynamic threshold algorithms that are comparing all the same type of assets to one another. We are, while installing in the substation, we also install a weather station. So we compare the data with the moisture, temperature, wind speed, and wind direction. And it's all in the bundles where we can identify 7 scenarios of the anomalies in the behavior, and then we trigger. Yeah, then we trigger a recommendation.
My next question is regarding to your business model. So you have hardware and software, right?
Yes,
so
correct.
Is it necessary to like provide a bundle service, or actually if we have already installed some thermal camera in our substation, we already have some images. Will you consider to like separate this service, hardware and software?
So it is important to understand that our hardware is very special. We do analytics and the thermal behavior analysis on raw data, which is 16-bit, which is probably 20 to 30 times more sensitive than other devices. So our systems are used to work with our sensors. We can try, but I would not suggest because the biggest advantage of the system is really wide field of view sensors, really high resolution, and everything is happening on the edge, as I mentioned, right? So we are using raw data, decisions are made on raw data, and only then we come out, which other systems cannot do.
Final question for me is like, what is the typical coverage area per your like thermal camera? And like, is there any communication capability, like 4G module inside your camera? How to transport the data back?
So area, we can cover very large areas, and we can do, one device can do, for example, 3 hectares of the area. It a little bit depends on the level of detail that you want. It can be more or less. The system has the edge computing capacity. It works with the PoE. We can use any type of communication, so mobile network, wireless, optic fiber, yeah, any type of communication that is necessary. At the moment, the data comes to our server, and you get access to that server and that data. But we can also deploy it on the customer servers as well. Otherwise, what you saw in terms when I showed the software, that's what you get. This is the access that you get.
Yes, Maxime Godin from Hydro-Québec. Question here from our business unit. There's not much public information about your 180-degree thermal sensing device. Do you have a data sheet available? Or
Of course.
how many have been measured? So
Of course.
how many have you measured so far?
So the sensors have been on the market for about 3-4 years, and the initial application for Mitsubishi Corporation was for marine industry. So we have about 40 sensors mounted on very large vessels in Tokyo Bay. So they are very much TRL 9, and they have been battle tested and field tested, the actual sensors.
Where is the data stored? Can we host it in a private server?
Today, we don't use third-party cloud services. We are storing data on our own server in Stockholm under the lock and key, and we can do the same on your premise and your server as well.
Any further questions from you guys? No? Okay, so thank you very much. That was a great pitch. We'll get to you soon. Bravo, well done.
Thanks a lot. Let's do some pilots, people. Bye-bye. Bye-bye.
Bye-bye. If you could, yeah. Next up, we have Giovanni from Balun coming in online. Everyone. Hi, Giovanni. Welcome. How are you doing?
I'm good. Thank you very much. It's exciting
All
to
right,
be
so,
here.
welcome to Top 60 for Electrons. Well done making it this far. It's no mean feat. And so we have a lot of very curious and interested people wanting to know more about your solution. And to do that, you have 6 minutes to pitch, and as you know, followed by 4 minutes of Q&A. So I see you're ready with the slides up. Whenever you're ready, you can take over.
Perfect.
And go.
Awesome. Thank you very much. I hope you can see my slide. My name is Giovanni. I'm here to present Balun. As most of you know, electricity can only be sold with daily production forecast, meaning that I need to say, if I'm an energy producer, how much I will produce the next day so the grid can stay balanced at each point of time. If I deviate from what I said the day before, so I produce more or less than what I said, I get charged by the grid a so-called imbalance price for the amount of excess energy or missing energy. Now that there is more and more renewables that are mainly fueled by the weather, and weather is notoriously difficult to forecast, these imbalance costs are getting higher and higher, and the margins of renewable energy producers are getting lower and lower because current solutions don't capture the complexity of the problem. Therefore, how do current forecasters work? They take weather models. Weather models are models that are sort of happen in a computer where they say, okay, in a certain location, let's say in Canada somewhere, there is a point, there is a wind park. How much does the weather model say there is wind in a specific location? Let's say there is 10 meters per second. And then they take something that is called the manufacturer's power curve, that is in essence just the what the manufacturer of a wind turbine says, how much power is produced at any given wind speed. So at 10 meters per second, in this instance here, where we see the manufacturer's power curve in red, there is 1,400 kilowatts, somewhere around here. And this is how much they would forecast that production would be in that point with a traditional methods. If we want to take what is actually measured at the wind speed, so one takes the wind speed that is measured on top of the wind farm, and one sees how much electricity is actually produced at each point in time, you have all these blue dots that are roughly around the power curve, but actually are pretty far away. And this is exactly the type of problem that you can tackle with machine learning very, very well. So what do we do at Balun? If you think about a wind turbine, the wind turbine, depending on where the direction of the wind is coming from and how fast the speed of the wind is, they turn into the direction of the wind, and they have different pitch angle of the blade depending on how fast it is. Therefore, they correct with sensors data on how fast the wind speed is, how sort of the pitch angle, what it is, what the temperature is, how much power they're producing, and many, many more of these things. Because you have this data set for each turbine in a wind park, let's say we have 10 turbines with 10 sort of data sets that all specify over a timeline what the wind speed is and what the direction is, we have a pretty good idea of what the weather situation in a park is. With that knowledge, we can look at what is the best weather model out of all the different weather models that are out there for this specific location. Once we know what the best weather model is, and once we have this data, we can take that and train a machine learning model on the relationship between what was the weather forecast and what actually happened in this specific park. Meaning that if the wind is predicted to be south-southeast at 12 o'clock in a velocity of 10 meters per second, we know that from the data what exactly happens in these occasions, and therefore have some sort of correction factor that allows us to predict better how much electricity is produced and thereby reduce imbalance costs. This is sort of what we do. As an example, how that is beneficial to anyone, a turbine of 2 megawatts, this is like roughly an average turbine size in Austria, but also in rest of Europe, has a roughly imbalance cost of 60,000 euros per year. This obviously depends on which market you're in and what the season is and what the price level is, but roughly this is what one could say. If we reduce this imbalance cost by 20%, this is 12,000 euros per year that are saved per turbine. If one would extrapolate this to EDP's 11.4 gigawatts, this would be almost 68 millions that would be saved every year. And with more turbines, it would be even more. So why are we here? We would like to reduce your imbalance costs. For that, we would like to have a setup with one wind park, a duration of 4 months, where we get connection to live and historic SCADA data via an API. And we would do that for the modest sum of 15 euros per month per megawatt, which for a park of roughly 60 megawatts would total 3,600 euros. How can we go about that? Ideally, on Monday, you tell us, let's go ahead about it. We set up a call between the O&M team and the trading team and us. We discuss how we can get the data and how we should deliver the forecast to your team. Then you select the park that you would like to do the pilot on. We get the data, train a model, and from May onwards, we can start forecast and you can start to save on imbalance. And then hopefully out of that, we can grow further. Thank you very much.
Thank you, Giovanni. That was great. We have some questions for you.
Please.
Hi, Giovanni. This is Maxime Godin from Hydro-Quebec. Thank you for your pitch and congratulations on making it to the pitch event, the top 60 of Electrons. Few questions for you. How adaptable is your solution to, and especially your machine learning weather model to North America and say Quebec, for instance?
Very, I suppose. To be honest, the caveat I see is that we have less experience with the weather models that we use in Quebec. So we would have to see, we have a selection of different weather models, and we would have to see which one is the best for Quebec for that location. But the weather models are not ours. We buy the weather models, or we select the open ones. And what is like specific to us is just getting the scatter data and then training the model on sort of the correction factor from what was the weather forecast and what actually happens, and thereby sort of debiasing the weather forecast and add sort of the knowledge that is inherent to the wind park itself. Does that answer your question?
It does. So you also require from us SCADA data on each of the wind turbines.
Correct. That is sort of the bigger requirements. Weather forecasts you can usually find for all locations everywhere. What is really like what we work in is basically getting the SCADA data, cleaning it, and making it in a way that we can sort of have a data set that works well with the machine learning model. As mostly in data science, it's garbage in, garbage out. So having an accurate data set is the most important part.
Okay, and concerning the wake effect, do you need prior knowledge of the wind farm topology or terrain topology?
Not really. More of like the model of the wind farm, like the model and the hub height, like sort of the metadata of the turbine itself. But that's the beauty of like having all this data. The sort of the knowledge of the topology is within the data, because we know exactly how much is measured on each sort of wind turbine, and therefore we don't need any other thing except that data, sort of.
Okay, and wind farms in Quebec are located in a very cold climate zone with somewhat significant generation losses due to icing and cold weather. Do you have a model to predict those losses?
For icing, I have to admit we are not yet. This is something that continues to come up, and we are looking into it, but we don't yet have a model to predict that. But one has to say that if you have enough data for this and you have enough sort of instances for icing, what we do very well is like cleaning data and sort of building machine learning models. So we can definitely look into that. And we're very keen on doing that. We just like right now are focusing on doing like day ahead wind for day ahead and intraday wind and solar. Icing is sort of the next step on the product feature.
Okay, maybe just one more, and then I'll leave the floor to a colleague from another utility. So, how many years of historical SCADA data do you need to train your models?
The more, the better. But I would say that from 1 year onwards, we can have good results. Again, the more like 2, 3, 4, the more, the better.
Okay, thank you, Giovanni.
Yeah, two very quick questions, and thank you for the presentation. Andre here from EDP. The first is, how many megawatts do you have under management? And the second one is, if you only do wind assets or if you do other assets like solar.
Yes, so currently we have forecasting for 100 megawatts. I think by the time we reach the summer, it will be roughly 200 megawatts. Currently that we're forecasting actively for it every day, we are only doing wind, but we are sort of working on the solar solution and are expecting to deploy this by sort of mid to end April.
Thank you. Maybe one last question. Can your model run without live SCADA data?
Yes, it can run without live SCADA data. The main thing is that with live SCADA data, especially in the short term, it works a lot better. But we can also do it just like there is the setup with just historic data. Absolutely.
Thank you. Okay, Giovanni, thank you very much. That was great. Well done on pitching for.
Thank you. Thank you very much for this opportunity. And yeah, good luck with everyone else. Thank you. Bye-bye.
Back to you. Maybe not Monday, but we'll get back to you soon enough. Thank you.
Okay, perfect. Thank you.
So next up, we will have data bridge and Vladislav will be presenting.
Hello. Hello. Okay.
Bartos and
Let's
Rados,
go.
how are you doing? Yes, we can hear you. How are you?
Very
Well
good.
done, making to free electrons top 60. Bravo. You have here 7 utilities eager to know more about data bridge, its solution, and how innovation it is, how innovative it is. So the model is you have 6 minutes to pitch, and then we have 4 minutes for Q&A. We see your screen, and it has a login for data bridge. So are you to do a demo?
Yeah. Radek will play some movie in the background, how looks our application, and I will put some comments on top of it, okay?
Then the floor is yours. Go ahead.
Thank you very much. So nice to talk to you. That's great that we have presentation to talk a little bit about the data breach and our solution. Basically, what we are presenting today, it helps to maintenance wind farms, but not only in order to optimize in technical way, but mainly to optimize the financial output, because windmills are in blocks, they are in farms, there is many windmills. Basically, then they interfere each other, there is shadow effect on it. So basically, depends on which turbine you shut down, in which not direction, but in how you make a queue, which will be the first one, which will be the second one, and so on. Basically, you can also increase or decrease production on other turbines, and our application allow us to schedule maintenance with a connection to the day-ahead market, or basically any energy market, to plan and make maintenance in the way that allows to optimize financial outcome. Especially very good example, if we know that tomorrow we're gonna have very big production and negative price on the market, this is the best moment to make the maintenance. And the positive will be when we do not schedule it in the proper way. And basically we do the maintenance, for example, when there is high wind, but also high prices on the market. So we don't want to do it. Our tool basically models the farm, the wind turbines, but also interconnections between them, the correlation, how they influence each other. And by having this tool, you can schedule maintenance in the way that it should be. And it's getting more and more important because flexibility, I mean, the volatility of the market is increasing. The spread between the prices is more and more bigger. The outcome from the windmills is very big. So the small differences in the maintenance can bring very big impact. How work our tool and on which stage we are right now? We have one paying customer here in Poland. This is national incumbent. We did first deployment for him. We are on a stage when we are able to cooperate with other companies. To be able to predict in the proper way, we need SCADA historical data from the windmills, basically to adjust the model and to be able to do the forecasting. Next stage, what we want to do and to develop within 1 year is to put AI on top of it. In that respect, that if we add 100 new turbines, we don't have to, let's say, manually adjust the model, but basically it will be ongoing learning. And in this way, we will be able to easily deploy this tool to any farm, or is it offshore, or onshore across the world. One minor thing, but very interesting, of course, data and cleaning the data. In case of windmills, when we clean the data, we are building in the same time spin-off product, because some strange things in the data means that the wind turbines are not working in the proper way. So as a spin-off product, we are also developing right now tool that help to monitor how does the windmills are operating right now, and is there something wrong happening with the devices. And basically, I think this is it, because this is, working very simple and useful tool. If you have any questions, I'm happy to answer on those.
Yeah, okay, thank you, Bartos. That was great. Yes, we do have some questions for you.
Yeah. Thank you for the demo. I think it was very useful to see the tool in place. I'm Andre from EDP. Let me ask you a couple of questions to understand a bit better the solution. In starting with the way that you collect the data. So do you need access to the SCADA system? Is there a way? Are you using any sort of hardware device as well? So how do you access the data from the wind parks?
On this stage, we are not using any devices, and we are not integrated yet with the SCADA. Basically, what we are receiving are its export from SCADA in XLS format.
Okay, and then do you need access to historical data, and for how long? And
for now, yes, we need at least 12 months. And of course, we would like to be integrated with the SCADA. And it's not like that we don't want or we can't or we don't know how to do it. But basically, there is always with big energy companies, security issue. It's not easy to be, integrated with the SCADA system. But if we can do it.
Okay. And then how, assuming that you're not integrated with the SCADA system, to run a pilot project, with what frequency would you need data updates?
We don't need any updates of the data. We just need the batch of the historical data, let's say for 12 months. I guess most of the windmills are generating data in 10 minutes intervals. Wind forecasts are 1 hour. And basically, if we get those data, that's the only thing that we need from energy company. The weather forecast is on our side. And basically, then we are able to send you forecast of the windmill or the couple of turbines or the whole farm. And then within 1 day, or basically using this application, you can generate forecast for the next 48 hours.
Okay. And then, so you're saying that you also look at energy prices. So right now, in which markets can you get like day-ahead prices and so on that you use to improve the maintenance plan?
Okay, so to be honest, for let's say international pilot, the easiest way for us is just to work on a production, because I guess the weather and windmills turbines are not that different across the world. Right now, we are working on Polish power exchange data, day-ahead market, and so on. And I assume that most of Energy Group has already tool for the prediction of the market prices. It's something that we can also update, but we haven't done it before, to be honest. Yeah, we know Polish market, we can implement other market, but it might need from us some additional take a look on the market. If it's European market, then it's not a problem. We can do it within 1 or 2 days. But if it will be a market that is totally different than Polish, then we will need around 1 week to learn about it and see what are the specifics. And maybe one thing worth to mention, we have on board people that are experts in trading, in data science, and so on. So we know the market, but basically, if the market is totally different, we might need some adjustments.
Okay. So then what would be the ideal setup for you right now, taking into account the experience that you have and the product that you have? What's the ideal pilot setup for you?
Ideal pilot is focus on the production from windmills. Because to be honest, this application, this whole tool, those are 2 separate models. So start with the historical data from SCADA, give us 1 or 2 weeks, and then you can generate production from your wind farm, but not only from the wind farm, but also different combinations. If we shut down this or that, I mean, to schedule the maintenance and see what will be the best outcome. This is ideal pilot, because on a very short notice you see how does it work. It work, and you can see the results. And we don't want to stuck in the forecasting market prices on the pilot stage.
Any questions? If not, I have a very last question, which is, most utilities already have some sort of management tool to understand when to stop the turbines, how to run their management, operation management. So what's special about this tool? What's different about this tool that utilities are not able to do right away?
Because most of the tools are based on, like you said, on technical maintenance, not about the economic optimization. And because we come from the trading world, we would like to treat it as a portfolio management in a way to manage production of the wind farm to have the best results on the market. And basically, we can also feed our tool with external price forecast. So if you have it already in your group, when we put it together, we have already solution to not only keep the maintenance and do it when it's necessary, but also to choose the best moment from the financial point of view.
Okay, clear. Thank you.
Okay, thank you very much, Radoslav and Bartosz. That was a great pitch. Thank you very much from all of us.
Thank you very much. Have a great day. Bye.
Thank you. We'll get back to you really soon. Thanks.
All right. But I don't know what should I press now.
So in the bottom right, you have a button that says leave room. And if you press that, you'll go to the main room where you were before. There you go. Same with Radoslav, you can find the button. And yeah, there we go.
Hello, hi Fabio.
Hi everyone. Good to see you. Hi.
Great to have you in the pitch event of free electrons. Congratulations on making this to the top 60. It's a big achievement. We are here all in the room together and also online. Lots of people waiting to get to know your solution better. So whenever you're ready, you can share your screen. We will count 6 minutes for your presentation.
All right, there we go. I hope everyone can see the screen now.
Yes.
Then let me start. Hello, everyone. Pleasure to meet you, Fabio Oldenburg, one of the 3 co-founders of Develop Energy, a startup based here in Berlin. And what you see here already on the screen is our geoinformation system that we developed for developers of energy infrastructure. So the software that I would like to spend the first 1 to 2 minutes on to give you a short tour is kind of like Google Maps, where we consolidate over 2,000 different data sets, relevant data, to decide where to put energy infrastructure, solar, wind, PV, but also heat infrastructure, hydrogen. So to show you some examples, what we see here right now is energy infrastructure in Germany, things like existing plants, also plants that are being developed, electricity infrastructure plans, construction plans, etc. But of course, this also involves things like, well, nature topics, nature protection, water protection, and so on and so forth. So there's a lot of data that we kind of include in the app. And in addition to that, we provide the functionality to now use this data effectively. And here I would like to give you one very quick example, which is the development of a solar PV park. Here I have selected a few potential parcels for us, where I can now very easily run a test report based on predefined criteria. And now the software checks all the different data that sits in the background to show me if the site is suitable or not, and where there are potential conflicts. And in the last step, I could now even add or calculate the so-called buildable area. So basically the area that I can now build my PV modules on. And if I would like to do that in the last step, I could even render my PV plant here in a 3-dimensional way. So that is all possible with the app. There's multiple other things that you can do, but that just as a very quick overview. Where do we stand right now with the software? And here I'm switching my view now into my presentation. Hope you can see the slide now, summarizing a bit our status quo. We have more than 100 customers in Germany that are using the software as of today for PV storage, wind, hydrogen, and heat infrastructure developing. More than 1,300 users of different departments, 53 users from E.ON, which we are very happy about, of course, also here from different departments. Around 1,000 daily visits, more than 20,000 energy projects that are registered in different stages. So we really nicely also see where the energy system of the future is being developed, the decentralized system, and the whole thing is fully bootstrapped. We are right now achieved 1.7 million, more than 1.7 million euros in annualized recurring revenue. So the software is currently monetized in a software as a service business model. Right now, we are very, very much looking forward to a strategic partner to do two things. One, expand our product portfolio, and two, to internationalize. And more precisely, this for us means verticalization of our product. We are, for instance, we would like to connect the different developers within each other. We started that already with a process called cable pooling, where we pool the different production capacities to unlock efficiencies and save costs in the infrastructure planning. We want to build an interface to the grid operator to automate and facilitate the grid application process, the grid connection process of the energy infrastructure that is being planned on the platform. And we would like to connect also the production capacities with electricity consumers in the next step. And on top of that, of course, it would be nice to leverage the software and the data processing technology in place today that is perfectly working for Germany, also in other relevant markets, so that other infrastructure developers can benefit from that. With that, I'm at the end of my very short introduction presentation, and I'm very, very much looking forward to your questions.
Very good. Let's move right to that.
Okay, so let me start with a few questions. Thank you, Fabio, for the presentation. It's Andrea here from EDP. It was good to see the demo combined with some explanation on the technology. Let me start and also looking at this slide that you have here to understand your capabilities in terms of different geographies, meaning you're right now mostly in Germany, I would say. What does it take for you to be available in other markets, and which markets are in your roadmap for short-term development?
Yes, thanks for the question. So what we can use one-to-one is basically the software infrastructure and lots of the data processing technology. So that is the point here. What we still need is to build up the data infrastructure, so basically the access the data in other markets, which can of course be very different, right? In different countries, you have different requirements to plan energy infrastructure. That's why the data is different, and their support is is needed with the specific local knowledge. So we understand very well what it takes to plan energy infrastructure in Germany. It would be very interesting to have a partner that is also active in other markets and can support us there, for instance, by telling us what data is required to plan energy infrastructure in other markets. In terms of roadmap for us, of course, kind of the European landscape is a priority, because there is, of course, more similarities to Germany due to European regulation. And within Europe, I would, of course, focus on the larger energy markets, think France, Poland, maybe, and tackle them first.
Okay, very good. And then in terms of renewables coverage, so you mentioned 100 customers between different technologies. So PV, solar, PV, wind, storage, how much does that represent from your traction right now?
Of the customers, it's around 60% PV developers, 30% storage, 10% wind. And then there is some first customers that are also developing other things like hydrogen and heat infrastructure. I hope this answers your question.
Yeah. Okay, and then in terms of the data layers that you use in the demo, I think you're starting to cover in that. Can you give some more information on the different layers that you use? You're mentioning nature, but I was wondering if you have like the terrain constraints, any information on landowners, the renewables potential taking into account things like irradiance or wind speed, then also information on the grid. So what data layers do you have, and what data layers would you like to have as well?
Now, I'm jumping back into the app. Everything that you mentioned is in the app right now, except for the landowners, but the land that is for data protection reasons. But we can, from the app also, we automated the ordering of landowner information, so we can get the landowner information. Things like relief, even things like construction plans, like the regional planning, everything is including the other things you mentioned, of course, electricity infrastructure. And we even go beyond the existing infrastructure and also access data on infrastructure expansion, right? We can see, for instance, from scraping municipality websites and accessing municipality plans, where are PV projects that are currently being developed and that might come online only in 1 or 2 years. We can see things like redispatch measures. So that means where are electricity grids currently being curtailed? How much energy is being lost in this thing? So the information that is accessible is quite broad.
Okay, thank you. Saoirse, go ahead.
Sorry, this is Saoirse from ESB. Just one quick question from me. If the list of developers competing for the sites, are they known to each other in the B2B2C model?
Sorry, could you repeat the question again? There was a bit of noise.
The developers who are using the system,
Yes.
are they
Yeah.
known to each other, in competition with each other, but can they have visibility of each other on the platform?
They are competing with each other. So that is one of our kind of technical requirements, is of course to keep their data or protect their data and also keep their information that we gather from them separately. So they can't have visibility of each other, except if they want to have that. And that is possible. They can, for instance, register a project that is being shared with others. For instance, if they are interested in local competitors, which can then become partners to connect together to the grid to save costs in the grid connection. So it is possible, but generally in the first version they are competitors.
Perfect, thank you.
Very good, Fabio. Thank you very much for your presentation. The time is up.
Thank you. Was a pleasure, and have a great day.
Thank you. Thank you very much for being with us.
Bye.
Bye. Okay, very good.
We are moving right now to Powernaut. It will be Florentin from Belgium. Hello, hi Florentin. Great to have you.
Good
Welcome.
afternoon. Should I say good morning? Because I believe that you're all in Canada, correct?
That's right, that's correct. We are, good afternoon for you, for sure. We know you're dialing from Belgium. We are very happy to have you. Congratulations as well on making this to the top 60. We are all in the room here, more than 30 of us, representatives of all these utilities as well. And you can see many people online. Very eager to get to know your solution. Please share your screen. We will count 6 minutes for your presentation, and you can start whenever you're ready.
Perfect, sounds lovely. Sharing my screen. All set up from your side?
Yes, we are ready.
Lovely, perfect. So great meeting you all, and great to also be talking with you about flexibility, the energy transition, and also our solution in the next few minutes. My name is Florentin de Grote. I am co-founder of Powernaut and taking up the commercial role within the company. And we have started our business because a few years back, we saw a huge problem, a huge challenge in the market, and that is that energy suppliers are struggling to capitalize on the energy transition. And we're seeing that portfolio management is becoming increasingly complex because we're all installing renewables that are harder and harder to forecast production for. As a result, we're more exposed, let's say, to imbalance and also wholesale spreads. And we see that the P&Ls of utilities are really hurting as a result. The first signs in the market show that some utilities are already working on a new type of supplier contract, allowing customers to be valorized for their flexibility and also compensated for their flexibility, also running the risk of those suppliers lagging behind to lose market share in the process. And so those three key topics, I'd say, are things that we as Powernaut try to address, things that we solve for our customers as we make the retail and the demand side rather of energy suppliers tradable. How do we do that? First of all, we aggregate your retail sites, and we do so via two ways. We do not only aggregate existing original equipment manufacturers through cloud connections, think about inverters, home batteries, electrical vehicles, and so on. But next to that, we also allow for an integration of third-party energy management systems. And by that account only, we have, let's say, we span more than 70,000 households all across Europe already, span almost 400 megawatts in installed volume, and do so for the four main asset types. It's not only about aggregation and connectivity, it's also about forecasting. So within our platform, within our visual tool, we're able to show to traders how their positions look like, not only now, but also towards the future. We help them nominate on the day ahead, better and more risk-free than ever before. And we keep track of how that portfolio, let's say, evolves towards the futures in order to, first of all, facilitate portfolio self-balancing. If we see that the positions are misaligned with the actual day-ahead nominations, or optimize for wholesale trading opportunities, think intraday, for example. And then next to that, when we come close to the point of delivery, our software allows for ancillary imbalance and also congestion remuneration in order to make most out of flexibility. It's really, you could say, a multi-market approach that we're taking here with our customers. And then next to that, apart from, let's say, aggregation and forecasting, we also integrate seamlessly into existing software. And so first of all, we're talking about the trading desk. We allow for market access that is already established within the company through our APIs. But also next to that, the billing desk. We find it very important to allow for customers of energy retailers to also actively take part in the energy transition and thereby be compensated for flexibility, but also do so in, let's say, transparent ways. So our platform and our software allows energy suppliers to, in an individual basis, understand profits, revenue, and costs per customer installation. And then thirdly, we also allow those suppliers that do not have their own application ready to roll out in flexible ways to use our standalone or integrated white label customer interface, allowing suppliers to show to their customers an interface in which they can select the type of inverter, the type of car that they have within their systems in order to be onboarded in a very smooth and elegant fashion. Our open VPP is established. It is battle tested over the course of the past year and a half by both established partners, think about Luxon, for example, or Innovoltis on the right-hand side, but also by our customers. We have, for example, Bolt, a Belgian energy supplier matching supply and demand on a local level, let's say, but also next to that, a very prominent, I think, energy supplier that we're working with in the Benelux region that we were able to share this code of, but is still under NDA. So it's definitely keep following us on LinkedIn as this will be announced very, very shortly. And the results that we were able to accomplish with them are shown here. On average, we're able to, for residential home owners, let's say, save up to 400 euros in profit per year. And we've seen that our customers have been growing their customer base as a result organically by creating this new type of supplier contract, which allows customers to save up to 32% of their energy bill. We were also asked by Beta I to think about, let's say, a proposition to you guys. And what we've seen work well is to start with a pilot, to start with a test in order to double-check integrations, in order to make sure that this small-scale demand-side VPP for the first time ever can be tested. And we would propose to start with 10 solar installations, 10 home batteries, 10 EV installations of existing customers and have these valorized on both day-ahead as well as imbalance or congestion markets, for example. What we've seen work really well, and that has also resulted in follow-up, let's say, rollouts, is a project lasting about 4 months, 5 months total, in which we take 2 months to understand each other business requirements and also engage customers to then start testing for 3 months on an end. As I said, my name is Florentijn de Groote, co-founder and CEO of Powernaut. Super happy to have been talking with you about our company so far and looking forward to the questions that you might have.
Perfect timing. Let's move to questions.
Hello, thanks for the pitch and congrats that you made it to top 60. So I'm Mochi from Jeddah. So let me start from the value proposition. So I assume that there's some competitor in flexibility services or market. So what is the kind of biggest challenge you have encountered in customer adoption, and how are you gonna addressing them?
Yeah, if I understand your question correctly, it revolves around what is our biggest concern or challenge, let's say, that we see rolling out these types of solutions. Is that correct?
Yeah.
Yeah, perfect. I'd say customer engagement is one. When we think about the energy transition, it's all about getting customers on board. That is true for residential customers as well as C&I customers, which is, let's say, our target focus. And getting residential customers on board is not trivial. It's a hard concept to explain to them that they can get grid rewards or any other, let's say, reward system for their flexibility. So we help energy suppliers also thinking about ways for them to create this type of contract, also to market this new type of contract so that as much people can be onboarded in this energy transition and be valorized for flexibility.
Okay. And how are you gonna addressing those concerned in your business future? Yeah.
Our mission is to make decentralized energy easy and beneficial for everyone, and especially that first part, we're making it practical by communication, by allowing our customers to communicate effectively, let's say, to the customer. And so also within the pilots, for example, we have made, let's say, marketing plan of attacks. We have worked together with marketing agencies to tailor those messages to those customers to make it as easy as possible. And also within our front-end applications that we show to customers, we really explain the concept of flexibility and also allow people to engage, let's say, if they have questions. Also on the roadmap is to create chatbots so that people that have extra questions, additional questions, can get answers without overly, let's say, overloading the customer support services that energy suppliers offer.
Okay, thank you. So close to the past question, but again, flexibility market is expanding not only Europe but the other regional perspective. So what do you think? What's the biggest risk or barrier in the flexibility market, and how you're gonna mitigate those risks?
Yeah. When we're talking about risks and let's say integration barriers, I think legislation is definitely something that is of concern, which is also why within a new country that we're tackling, we want to understand together with the customer how that will change towards the future. And also looking at, for example, the European, let's say, landscape, we understand also that there are other types of energy production being pushed these days by politics. Think about nuclear, for example, providing stable baseloads, allowing, let's say, some thoughts to be had around the flexibility markets to the future. But with our customers, we're collectively looking together into which markets are most attainable, easiest to access, and easiest to valorize. In the Netherlands, for example, that is congestion. In Belgium, that is passive imbalance. In Australia, for example, Southwest Australia, that's also imbalance these days. So it's an exercise that we do together with the customer.
So if I may, I want to have one more question. So yeah, I understand the way that you have the customer, both end user, so residential customer, as well as like the utility company like ours. So and what kind of I just want to understand more about our perspective. So could you tell us how you're gonna ensure us the financial benefit of participating in your platform?
Yeah, we have set up a flexibility verification mechanism that allows, let's say, us to prove to our customers how much flexibility has been procured, at which costs, and at which revenue, so that we can calculate profit. And this flexibility verification mechanism shares data, let's say, with the utility that we will collaborate with, so that they can cross-check the data that we have at hand with the internal data that they get from, let's say, DSOs, for example, or their own digital meters that they have installed. And by that account, it is, I think, proprietary software that we have built. By that account, we allow energy suppliers in a semi-automatic way to verify the amount of flexibility and the price of flexibility that we report on our platform.
Very good. Thank you very much. Florentin, that's the time is up. It passed very, very quickly. Thank you very much for your presentation.
Thank you so much and have a great day ahead.
Thank you. What a pleasure to have you. Have a good rest of the day, and we will for sure be in touch.
Thank you. Ciao.
Thank you. Goodbye. Okay. And let's go right now to SolarPlex. It will be Alex from Ukraine. Right in. Now that we are ready.
Hello, everyone.
Alex. Where are you? I must ask. You're in a very nice place.
Thank you. I'm trying to, at least in my thoughts, move out of Ukraine, which fights and struggles in the war with Russia, to somewhere peaceful and like a seaside. So just a virtual background, but it makes my mind be calmer.
Very good. Very good. Alex, great to have you. Great to see you again. And also one more time, congratulations on making this to the top 16 of Free Electrons 2025. We are here all gathered, eager to get to know your solution better. We can see your screen very well. So whenever you're ready, start. We will count 6 minutes for your presentation.
Okay, perfect. I'm ready. Let's go. Can I start?
Yes, go ahead.
Okay, so let's start right with the problem. 25% of energy is lost on every solar panel you've already installed. The same is true for each new panel you are going to install. How big is the problem? It's huge. Every year, all PV panels worldwide lost about 300 gigawatts of energy. That's compatible with the total amount of PV panels we install worldwide. What's more, we are losing $26,000 per average residential solar power plant because we don't use the sun to heat the water we need. And we don't have enough roof space to install PV and thermal panels side by side. The SolarPlex product offers a unique solution to this problem. An upgrade pack to use on both new and existing panels to get both electrical and thermal power from a single panel. Our solution allows you to generate 10% more electrical power and 4 times more thermal power. Now, let's talk about competitive advantages. First of all, our solution has the lowest levelized cost of energy among similar solutions that provide electricity and thermal power with the same operational cost as for PV or thermal systems. Moreover, we offer the highest amount of energy produced per square meter. Our solution opens a totally new market opportunity for you, the market of locally produced thermal energy year-round. Operation cost is the same as for PV or thermal systems. With SolarPlex, you get 5 times more revenue and 2 times faster ROI. Our project is compatible with these 5 UN sustainable goals. One of the utilities we are talking to today is E.ON, which is active in Romania. In Bucharest, just by deploying SolarPlex technology widely, the city could reduce annual CO2 emissions by 25 tons per average residential installation. For all residential only in Romania, it means 90 million tons. This is especially powerful, considering Romania's total emissions are around 70 million tons annually. To illustrate the scale, SolarPlex could even help entire regions achieve their carbon neutral targets as the technology easily scales with available rooftop spaces. Romania has good solar irradiation, yet it cannot compete with locations like Australia, Portugal, or other countries where participating utilities operate. Thus, your potential economic and ecological benefit from SolarPlex will be even higher. SolarPlex is the perfect opportunity for rooftop solar power plants. This allows you to produce and use energy right on site. Moreover, we are able to upgrade industrial scale power plants. Just make sure you know how to use all the thermal power we can produce. Now, let's move to the pilot plants. We identified that we can work with all utilities except JER and Hydro-Quebec, as they don't seem to be interested in solar projects. With the rest, we plan to build different types of SPPs to prove our efficiency and economic benefits. This includes a 5 kilowatt home solar plant, a 20 kilowatt solar power plant on high-rise building, and a factory's 20 kilowatt solar power plant. The total budget for pilots is $150,000. The facility creation is 2-3 months. Manufacturing and installation would take also 2-3 months, and a full annual cycle for monitoring and analysis. There are 4 metrics that would prove our performance: an increase in electricity generation, total heat production, reduction in operational panel temperature, and reduction in levelized cost of energy. So the next steps involve scheduling a meeting to discuss the details, signing the agreement, and implementing the process. Let's launch SolarPlex pilots to boost energy production, reduce costs, and gain your competitive advantage within a year. Thank you.
Very good, Alex. Let's move to questions right now.
Thank you, Alex, for the great presentation. Congratulations for making it to top 60. My name is Ivan from CLP. To kickstart, I want to ask you, do you have a technical specification sheet that can show us, which contains like the size, dimension, the power output? I mean, you show the power output in total, but what are like inside the power generation and the hot water output? I want to see.
Do you mean the physical dimensions of our upgrade pack, or what do you mean? Sorry, I didn't understand clearly.
The size of your solar panel, what is it?
We do not produce solar panels themselves. We just upgrade them, but we do not make them bigger. And we can even mount the upgraded panels on the same mount systems you use for regular PV panels.
So you only do the upgrade part?
Yes, exactly. We take new or existing PV panel, upgrade them, and you get 2 energies from the same PV panel.
Is it applicable to like all the different solar panel types?
Yes, it can be used on existing solar panels or on the new panels.
Okay. So in terms of like different geographies, how do you plan to like roll out your business in like different countries? Given like you may need to like fly to different cities to install your upgrade system. Is that right?
Sorry, I didn't get your question. Could you repeat, please?
What do you plan to like do this kind of upgrade by local contractor, or you have a
okay, yeah, I see. We do upgrade process ourselves, but we are looking for local partners, and we are ready to work with local partners who can make upgrade process. So if there are solar plants installers who already do engineering and they are ready to take on a new opportunity, or it's your engineering team as a utility, you can do this upgrade yourself with our technology.
Your upgrade, that panel, is it standardized?
Yes, the process.
Standardized product?
Yes, the process could be standardized. We are going to, with pilots, through the process of standardization, and then we can give the standardized procedure for this upgrade process.
My last question is like, have you done any pilot yet?
We have one panel in Odessa, in Ukraine, which works for 4 years already, and it proves the result we are saying in this presentation. And now we are looking for more pilots to be built in Ukraine and all over the world with the utilities.
Any questions?
That's everything?
What is the indicated cost of your upgrade panel? Just talk about the panel cost without any like installation work, upgrade work. What is the cost?
We are saying that our solution with PV panel could be $350 per panel, and considering $50 is the cost of the panel and $300 is the upgrade process.
So 50, right? 50 US, 50 euro, 50.
No, the upgrade pack is 300 and 50 could cost a PV panel, which we can buy on the market.
Oh.
The total
Just
cost is
without any works is already $300.
Yes, the upgrade process costs $300 per panel.
Okay.
Alex, it's Liam here from Origin Energy in Australia. Do you envisage any warranty issues if you're applying it as upgrades to new or existing panels?
Yes,
any
that's correct. Sorry, you were asking that either we are working with new and existing panels, correct?
Yeah, and my question is, do you envisage there being any warranty issues associated with the upgrade?
That's a good question. We were talking with several PV panels producers to keep the warranty. But in case we don't have this PV producer working in Australia, for example, we can give our warranty for our upgrade process. And this way we can have the same warranty as the PV panel producer gives. But our projection is that we can increase the panel's term of life cycle because with the lower temperature and we make the panel cooler, the panel would increase its lifespan.
Thank you very much.
Very good. Thank you very much. And our time is as well up. Alex.
Thank you.
Alex, thank you very much for being here with us. It was great to have you.
Goodbye.
Rest of the day. Thank you. You can click on the bottom right to either. Very good. Let's go to our last startup, last presentation. It will be SunOyster. We are waiting for Carsten. Hello. Hi, Carsten. Amelie.
Hello,
Great.
how are you doing?
Yeah,
Hope you
very
are
good.
still fine after this long week.
Yes, you have a very, very special slot. It is the last one.
Oh my God.
Of the whole week, so you know, no pressure, but everybody will remember this well. Great to have you. Welcome to the top 6. Welcome to the pitch event, and congratulations on making this to the top 60. We are all ready, so you can share your screen. We will count 6 minutes for your presentation.
Yes, fine. Can you see it well?
Yes, we can see it well.
Fine. Yeah, so welcome to my presentation on innovative PV lightweight modules. They are a very versatile tool for generating cost-effective green electricity. My name is Carsten Corino, and I'm the founder of SunOyster Systems. SunOyster Systems is a startup based in Hamburg. We are coming from solar trackers, manufacturing solar trackers, and our experienced team has already satisfied customers such as Siemens Energy or the German railways. Our customers have made us aware of the following problem. Many commercial roofs are not suitable for conventional PV. Take, for example, the roof on the picture. The architect said it can only bear 15 kilograms per square meter. However, ballasted PV weighs 3 times as much. So, what's the solution? The solution is gluing the modules to the roof. By doing that, you can save roughly factor 10 of the weight. The modules which you see on the picture are made of polymers. They are using silicon cells, normal cells, so they have roughly 20% module efficiency. Also, the certifications and the guarantees of the modules are very similar to conventional modules. There is another type of PV lightweight modules, and we are the pioneers in using them. They have a glass front and have some properties which make them even better for roof surfaces. Their surface is smoother and stays cleaner. Moreover, they have the optimal stiffness. And finally, they are even more cost-effective than the polymer modules. If you know how, you can glue on basically any surface, from PVC foil over metal sheets to glass surfaces. However, there's nothing which cannot be made even better. So we have some IP rights for novel lightweight PV. These are glass-glass modules with an integrated substructure and an integrated multifunctional edge protection. They offer not only a higher yield, they also have a better water, better fire, and better ultraviolet protection. We are selecting partners in China and in India to manufacture these modules for us. How could a pilot with these modules look like? Let's take the example of Galp, an oil company which operates 1,400 service stations in Portugal and Spain. These service stations have very light roofs, and normally our lightweight PV modules are the only PV solution for these roofs. So we have delivered in January 1 pallet of these modules to Galp, and in the second quarter of this year, they want to install them. This will result in a pretty low life cycle cost of electricity in the range of 3 euro cents. As the service stations also have a high consumption and can consume all the electricity generated, Galp can earn on these service stations for each one roughly a cash flow of 100,000 euro over lifetime and can save 600 tons of carbon dioxide. But of course, pilot projects would also be possible some numbers bigger. So for example, the free electrons utility E.ON is in touch with us regarding a project idea for putting the lightweight modules on the soccer stadium of Coventry, which would be more than 1 megawatt on the building here in the front. Altogether, we believe that the PV lightweight modules are so versatile and can be applied in so many fields that the technology can conquer installations of thousands of megawatts worldwide. Yeah, we hope we are ready for your pilot project, and we would also appreciate your participation in our PV Light GmbH, which is to be founded. Thank you for your attention.
Thank you very much, Karsten. Let's move right away to Q&A session. 4 minutes for that.
Hallo Carsten, hallo nach Deutschland. Samuel here from E.ON. Thanks a lot for your presentation and congrats for making it to the top 60.
Thank you.
My first question would be on the durability of your solution. Do you have any stats on that, which you could share with us?
Mm-hmm. Well, the glass modules have a very similar setup as the conventional glass foil modules, just without the frames. So it's no wonder that the guarantees are 12 years on the product and 25 years on the performance. And of course, to the system belongs also the glue, which you can see here on this roof. And the manufacturer of this glue is a European company which has collected early experience with the system, has also thoroughly tested it in the climate chamber, and they give a soft guarantee of 10 years on the glue. And the values of this glue, they have such high securities in fixing it to the roof that we are very confident the glue can survive the same 25 years as the modules should.
Perfect. And talking about the glue, what happens if we want to remove some of these panels and they are glued to the roof? Because for some of our commercial customers, it's not such an unrealistic scenario that they have to do some work on their roofs.
Yes, that's absolutely correct. And just a few days ago, our team had this case that some service staff for windows on the roof destroyed 2 modules. And so there you can cut them loose with a cutting wire. It is the same procedure as with the window panes of your car. They are glued with a similar glue to the metal. And also there they use such a wire to cut it. And facilitated is that by the fact that you always have a relatively high glue beam. So after gluing, it shall be at least 3 millimeters high, allowing you to guide the wire through the gap without damaging the skin of the roof.
Okay. What are your experience in the training for our technicians? How difficult is it to learn like the installation process of that, or is it more or less standard?
Yeah, it's not very difficult. So a talented do-it-yourself craftsman can do it. We offer 3 different forms of training. The simplest one is just the written guidance, a manual of, I think, 30 or 40 pages or so. And then we can do a video conference of 1 hour. Or, of course, the best, if you want to do it on a continuous base, or if you have a big and expensive project, then we send somebody for coaching 1 or 2 days. And then the staff perfectly masters the procedures.
Okay, got it. And I remember from your deck that or from your application, that you mentioned a couple of other products. Can you elaborate a bit more on your current focus setting from your company?
Yeah, well, I briefly mentioned trackers. So we have there developed 2 types of trackers. This is the backside of a tracker using mirrors, concentrating the sunlight onto a receiver, where it generates in any case heat, and in some cases with our hybrid receiver also at the same time electricity. And then secondly, we have used the know-how gained with these SunOysters here to manufacture biaxial trackers with PV modules, enhancing the electricity production by 30 to 50% compared with fixed modules. So these are ongoing activities in our company, but yeah, we feel that the PV lightweight modules are a very dynamic field and have a lot of traction in the market. And so our idea is to concentrate the lightweight modules in one new company, bring also the IP rights to this company. And for that company, we are very interested to take in shareholders such as venture companies from your groups.
Thank you very much, Carsten. The time is up. Thank you for your presentation.
Okay, thank you. Have a nice weekend.
You too, likewise. Have a good rest of the day and the weekend. Thank you.
Bye-bye.
Goodbye. Here. Let's take time to.
Yeah, so now we do the same procedure. You do your analysis, and afterwards, right afterwards, we do the debrief with the 8 startups, closing remarks, and we'll give you some more pointers on the rest.